talk above dawn? If I talk, am I on or Calvin?
I don't think we're picking Laurie up.
We're not.
Is your mic on? Or?
My mic is on, right? My mic's on. You can hear me?
Oh, okay.
No, you can't hear through this. Oh, okay. Huh. Oh, maybe it's only through the. Oh, that was okay. Maybe I should walk out there. That should be okay. All right. Okay.
We're ready to go.
All right, Calvin. Thank you. Thank you. Okay. So, welcome everybody. My name is Laurie Roche. I'm one of the people that's on the board of directors of the Friends of the Dominion Astrophysical Observatory. That's a horrible name for any organization, but that's what we call ourselves. And I'm hoping that tonight you'll be able to get a chance to, if you haven't already, to get up and go over into the dome and have a tour over in the dome. After this presentation, there will be a dome tour at 9, and then at 10 o'clock, because it's so gorgeous out, that we'll be opening the telescope and taking pictures and being able to present the pictures that are from the telescope up onto the well. So if you can stay a little bit longer tonight, there will be things happening up in the dome, and that's really special because sometimes we've had lots of cloudy nights on Saturday night, so we're happy to do this. Tonight we're really happy to introduce you to David Lee, a good friend of mine that I've now known for 20 odd years. I think it goes back at least something like that. I think
it's a long time.
We had a little bit less. I had a little bit less gray hair than I do now. David is a member of the Royal Astronomical Society of Canada Victoria Centre. He was the president of that organization a little while ago, and since he retired as an IT guy, an IT tech person for sure, from the provincial government, he has even kind of come in even more and done so much for our organization. We're really very happy to have him here tonight to give a presentation on Kitt Peak. And if anybody has been to Kitt Peak? Has anybody been down in Tucson area? Okay. Oh, you're going to be in for a bit of a treat tonight. It is really gorgeous down there. And David, I think you took that as soon as you retired.
Well, actually, it was before I retired.
Even before you retired.
It was a warning to my employer.
There you go. That you were going to go and do this. And since then, he has been doing all kinds of work with us in getting things ready to reopen the center. And he is totally knowledgeable about the sky and about how telescopes work. And we couldn't do without David. And so when we asked whether or not he would do a presentation, he said sure, which we're really happy to have him be here tonight. So David, I'm going to turn it back over to you.
Great.
And at the end, I'm not sure, Calvin, are we going to do, is David going to just redo the questions from the, anyway?
Yeah, that's okay.
Yeah,
whatever.
Just kind of take, because what we're doing right now is we are streaming to YouTube right now. And just puff your hair up a little bit. And we're also streaming on our Zoom, on our virtual Zoom connection, so that people that weren't able to get tickets are able to get into the presentation tonight. So we've got 3 things kind of going on all at the same time. So after the presentation, then we'll make sure that if you have questions, we want to be able to have the people in the other audiences also be able to hear what you're asking. So that's why we might have to do a little bit of work on that. Okay, so I'm going to give it back over to you. Thank you, David, for coming.
Thank you, Laurie.
Okay.
Yes, and welcome all of you. I think I did ask whether anybody's been to Tucson or not, but if you haven't, welcome to my vacation pictures. The other thing I wanted to tell you was please pay attention to the landscape, because something happened recently. It doesn't quite look like this anymore, unfortunately. But this is an amazing place. You can actually see from here, this is a mountaintop. This is like almost 7,000 feet above Tucson. And basically kind of lush kind of vegetation all the way up. And you'll see as I take you up the mountain what it looks like. So it's just kind of like a winding kind of mountain road. And then suddenly these little telescopes start to appear. So this is the layout of Kitt Peak. You actually see this area here first. So when you're going up the winding mountain, it whips around here, and then it comes past these telescopes here. This is probably the most famous. It's the Mile 4-meter telescope. And you'll see that in the pictures. But then you wind your way down here. There's a visitor center here, and then various telescopes. And we're going to visit the really key ones tonight. So yeah, home to 22 telescopes, including 2 radio telescopes. So here's an overview. I took this from there's this glass catwalk around the Mile telescope. I'm actually in it right now and looking out over the landscape. So it's quite a famous telescope. This is the Bach Telescope. These are the Space Watch telescopes here. And this is quite famous. This is almost a triangular formation. This is actually a solar telescope. So tonight we're going to have a pretty close look at this one here. And then various domes are kind of sprinkled all over the landscape here. And I'll tell you what this thing is here in a couple of minutes. So why did I go? Well, I had an opportunity to go to a imaging workshop. So I'm an astrophotographer, and at that time, the program called PixInsight was relatively new to me and to probably even a lot of the members here in Victoria. So I went to partake in a workshop to learn a little bit more about the imaging software. And also, it was just a thrill to be someplace that was so historic as Kitt Peak. And I'll tell you the reason why as we get further into this, this presentation. But it's kind of like the home of investigations into dark matter. There's so many famous astronomers that got their start there. Yeah, me, that's me, that's David Lee. So I decided to kind of climatize myself. So I landed in Tucson and I stayed at this, I think it's Lodge of the Desert or something like that. So I stayed here for a couple of days, I guess. And it was quite nice. Kind of chilled out a little bit. So I didn't really chill because it was really hot. So I laid out all my stuff. I didn't forget anything this time. I'm quite famous for going places and forgetting things. This time I didn't forget anything. So packed all my bags, packed my little tracker. Everything followed me from the airport. So that was good. Then I got this note from, now Casey Good is a fellow who teaches astrophotography courses up at Kitt Peak. And he sent this email. It says, hey everyone, as you probably noticed, the weather isn't looking too great with a gusting winds up to 45 miles per hour. Now, this is never good around telescopes because telescopes have a limit as to when they can be open. And if they get too gusty, you can't open them up. So this wasn't sounding very good. Anyways, I figured things will clear up. That's usually how it works, right? Well, not always, but that's what I was thinking to myself. And when I was driving around in Tucson, I saw all these little dust devils. So that didn't make me feel very good. So anyways, I went anyways. And on the day that I had to go to Kitt Peak, I drove out of Tucson and I landed here. So here's a sign for Kitt Peak and 12 miles up a winding road. So here I am in my rented car. And there's a little dome up here. That's the Mile, the large 4-meter that I was telling you about. So it's kind of visible. Behind all this, on the other side, were all those telescopes. So you can see the roads are kind of cracked on the way up. Lots of rocks around here. We're gonna see the rock area here. I think these are manzanita bushes kind of like relatives of the arbutus tree, I guess. These are the bush things. I think there's one right there. It's manzanita. Oh, no cell service. Don't go there if you can't be without your phone, because you can't run a cell on the top of the mountain. So more of these bushes. And here, you notice how kind of hazy this is? That's the dust. So when I left Tucson, it was quite windy, quite dusty. So here's some more kind of rock areas. Now, I found out later that a lot of the rocks are actually covered with an epoxy or a paint to keep them from coming apart. Because you can imagine as you're driving up this road, you don't want to be hit by rocks. Now, here on the Malahat, we would have kind of netting and stuff like that. Up there, they felt it was suitable or okay to just use this paint stuff over the rocks. Well, here's another view. You can kind of see quite sheer drops. I need to inform you of this. I stopped every once in a while because I wanted to see what it looked like. So I would stop the car, get out and take a picture. And you can see the distance horizon, so quite hazy. In fact, almost layered. You can actually see it's fairly sharp here. Then there's another layer, almost like a painting. And then the distant area is quite hazy. So anyways, quite a sheer drop. I can't really demonstrate it from here, but these are far away. So it's quite a drop. And you can see more about the rocks. All right. Now, this is significant. This is Baba Kraveri Peak, this one here. I just enlarged it for you to see. Now, this is very important for the Tohono O'odham Nation that lives there. And in fact, the National Science Foundation that runs Kitt Peak is there because the Tohono O'odham Nation allowed them to be there. So it is sacred land. And this particular peak is particularly significant because the people that live in the area believe they came from that peak. So they believe they were, I'm trying to remember if it was mud or what it was they were made from, but they came from that peak. So you can see it's always present from Kitt Peak. Okay, so first glimpses. So I'm getting really close now. I've probably ascended most of the 12 miles of the winding road. So you can start to see there's the Mile telescope. I think that's the Bach, and I think these are the Spacewatch telescopes. Now here we are again. That's the Bach. There's one of the Spacewatch telescopes. So Spacewatch just means that they're used to sort of monitor objects coming close to us. So they're run by the University of Arizona. This is quite a famous telescope. And when I showed you that picture of the overview, I was standing on this area here. These are glass windows here, overlooking the area. Yeah, here's the Bach. Some people call this the spray can. It kind of looks like a spray can. Yeah, its claim to fame is it was used to view Pluto's occultation of a star in Sagittarius. Here's another view. So this is the backside now. So we've come up around the mountainside. We saw this first when we were ascending the summit. There's the Bach, there's one of the Spacewatch, and there's the other Spacewatch. So when you come into view of the visitor center is just on this side here. You can see all the names of the organizations that are involved in this. So the National Science Foundation is kind of like a governing body that oversees this area, and then all these universities are involved. Now, originally when Kitt Peak was created in the 1960s, it was actually basically developed so that institutions didn't have to own their own telescopes in prime areas. So people could make bids for telescope time and on these different telescopes. That really allowed a lot of universities to do research without having to own these telescopes and having, of course, the prime location. Having a telescope really doesn't mean much unless you're in a really good location. So here's a close-up of the names. Wisconsin is quite significant. There's a wind telescope, which is run by the University of Wisconsin. So here's, this is an interesting thing. When you get into the parking lot, just before you get to the visitor center, you'll see this very large mirror blank. This was originally used for testing the Mile telescope, and it was painted by a local artist. You probably saw this in some of the ads in the Instagram feed. Quite interesting. I think it's actually been restored. It was in pretty disrepair when I was there in 2018. I think this has all been repainted. Here's another view of it. You can see the planet, you can see Saturn, Mars. Okay, so this is the visitor center. This is one of the visitors' telescopes. Most of the visitors' telescopes are what are called Ritchie-Chrétien telescopes. If you're an amateur astronomer, you probably would be drooling right now, but since you're not, you don't have to drool. So yeah, there's a very, very nice Ritchie-Chrétien telescope sitting in this dome. This is the visitor center itself. It has a couple of really interesting features. I'll point these out to you. This actually, how many people have been to Mexico and been to Chichen Itza? People have been to Chichen Itza where they have the pyramid? Well, anyways, if you were there at Chichen Itza on the Yucatan, you probably would have seen a astronomical building. Now, it would not have housed a telescope because the Mayans didn't have telescopes, optical telescopes, but it was actually, would have been made up with observation holes in it so that they would line up at particular times of the year. They would be able to see significant things like Venus and other objects. So this is a depiction of El Caracol, or the snail. So if you ever go down to the Yucatan, make sure to check that out at Chichen Itza. And yeah, there's some Mayan elements here, which reference the El Caracol, and I think this may be depicting the steps of the large pyramid in Chichen Itza. Here's another kind of close-up of the Mayan characters. I should know who these characters are, but I don't remember now. Now, this was an interesting thing that I discovered at the visitor center. It's actually a sundial. So when I was looking at it, it's actually made by a glassmaker in Arizona, but it actually tells time. And in fact, I kind of measured where the sun was, and I did some calculations, and I noted what time it was, and it's actually pretty accurate, actually. I was surprised. And this is inside center, the Kitt Peak Visitor Center. So they have a model of one of the telescopes. I think this is the 2.1 meter. This is I think it's a 2.1 meter, though it could be the mile. You can't tell for sure. Anyways, they have various telescopes that are replicas or models of telescopes that are actually on the site. So this is what I was looking at my computer during the day. So this is PixInsight. It just looks like gibberish, and to most people, it is gibberish. But it does allow you to produce these beautiful images of the night sky. So speaking of the night sky, when I was there in the evenings, now I should describe what this is like. So during the day, we would have our workshop, or imaging workshop, and this is often billed as kind of like an amateur's astronomer weekend. So as an amateur astronomer, it's kind of interesting to sort of fantasize that you're actually an astronomer. So going up to Kitt Peak is kind of like that, because they put you up in the dormitories where the visiting astronomers are, and you have lunch with the astronomers, and you have a really interesting thing called midnight lunch. Has anybody heard of midnight lunch? I certainly had never heard of midnight lunch. I kind of looked it up, and I guess it is familiar to some people, like maybe to shift workers. But anyways, midnight lunch refers to the fact that when astronomers work, they work all night, right? So lunchtime is actually midnight. So, well, we were there for the astronomers' experience. So what we would do, now, this isn't really fair because we were up during the day when astronomers sleep, but we were up during the day. So we were getting no sleep, but it was only for 2 days. So that was okay. So anyways, we would meet around midnight and we would have midnight lunch. So they were serving lunch, right? And then we would go out and we would go and photograph. And this is what we did. So I think this is the first night that the class was out. So I said to Casey, I said, it's too bad I came all the way and the skies are cloudy. And then he looked at me and said, David, that's the Milky Way. So this is the Milky Way. So then you see the Milky Way here. It was pretty impressive. I think that same night, Mars was around as well. I think it's either Mars or Jupiter. I'll have to look up to see what it was. There were 2 planets visible. So here's a close-up view. This is quite interesting. They call this the rift, the dark area of the Milky Way. You see it more dramatically here. But it was windy, because I remember we were all out there with our tripods and everything was kind of shaking because it was so windy. So telescope tours, we were offered a lot of telescope tours. And the thing I remember most, being an IT guy, the things I remember most was some of the equipment from the 60s, because I actually, well, I don't quite go back to the 60s. I'm not that old. I am old, but not that old. And I just remembered all these magnetic tape drives, analog dials, and you'll see some of those, but no digital anything, right? And yeah, it was just kind of cool to step back in time, actually. Again, that me is me. So here's the 4 meter, the mile 4 meter telescope. This is the one we see when we just come up over the hill. And this is what's inside. A lot of these telescopes are quite interesting. They're quite different from anything that you would see if you were an amateur. They have these very giant yokes. Oops. They have these very giant yokes to suspend. The mirrors in the bottom, the instrument panel is in the bottom of this. And there's always like the secondary mirror that's up here. And then all these trusses that hold everything together. So what's interesting about the MILE is it's being used for the dark energy spectroscopic instrument called DESI. So this is what's going to do, basically create a map of dark energy. Now, I don't know if anybody knows what dark energy is, but when Vera Rubin did her studies up here at Kitt Peak, she was measuring rotations of stars or galaxies, and she discovered that the centers of galaxies were rotating at the same speed as the outer edges of galaxies. Well, that really doesn't make a lot of sense unless you think that, well, maybe there's matter that we can't see. So that's where dark matter was coined. The only way she could explain the results that she saw were the fact that there was something there other than just the stars. And now they discover there's even more stuff that we can't see. They call dark energy. So most scientists believe now that the majority of what's out in space is dark matter and dark energy. It's not really stars. I mean, the stars that we see are just a piece of the puzzle. So this is DESI project, a little bit of a description of it. So they're measuring dark energy on the expansion of the universe. It's a 5-year project, and eventually they should have all the data that they need. But they're creating this 3D map. So they are still kind of like a significant thing. Like, even though I describe this as a place from the 60s, they're still doing significant research. So this is the 2.1. This is quite famous. The 2.1 is in here, and there's something called the Kitt feed tower, which is this large column right here. So basically, this was one of the earliest telescopes that were used for both imaging and spectroscopy. So the Kitt actually enables spectroscopic work to be performed independently of the main scope. So both of these can be used independent of each other. So some of the first discoveries were the 2.1, detection of distant clouds of hydrogen gas, gravitational lensing, that's a big one. I don't know, anybody heard of gravitational lensing? So all those pictures, like including James Webb, recently published some pictures where the galaxies are kind of distorted and twisted. That's gravitational lensing. And then observation of a pulsating white dwarf. So this is a very good history. Very interesting history. And Vera Rubin, of course, I've mentioned Vera. So she began observing in 1963 with the 36-inch. And then I believe they used the 2.1 for a while. And this is where they did those rotational curves that I described. So here's another view. That's Casey, from the instructor from the course. He's standing in the elevated area. Massive pieces of metal. I can't really describe to you how dwarfing these feel. These are very immense instruments. You see the instrument package here at the base. These are the dials I was telling you about. No digital anything, just dials, analog dials. Actually, the 16 here. If we open up the 16, you'll see the same, yeah, basically from the same time period. And actually, when we locate objects of that, we're just dialing them in. So it's also famous for RoboAO, which is the adaptive optics instrument. So it was here for a little while. Like, basically, they shoot a laser up into the sky, and they use that as a reference point to keep the telescope kind of tracking on things very precisely. So it got moved to the Palomar, but it got its initial execution here. Oh no, the other way around, sorry. It was in Palomar and they got moved to Kitt. I don't think they have it anymore though. So, very famous telescope. This at one time was the biggest solar telescope in the world. This was renamed. This was originally called the Mcmath Solar Telescope, and they added Dr. Pierce's name. So now it's the Mcmath Pierce. Very novel telescope. There's as much above as there is below. So if you can imagine, there's some heliostats or mirrors up here that reflect light down a channel, which goes down into this bunker area. These are actually doorways here. So it gets down into the mountainside. I'll show you the interior because I actually traveled up the shaft. So here's another picture. There's stats here, and you can see the reflected beam going down. It gets trapped and then shunted downwards down another shaft. And inside are all these pipes, copper pipes. And I can't remember whether they're inside or outside, but they carry antifreeze to keep the chamber at a constant temperature. Okay, this is in the interior. More dials and needles. So light can come down here. That's one of the areas where light comes down from the shaft down onto the area here. We wandered into one of the storage areas and we found a box of solar plates. So I'm actually holding a glass plate with an image of the sun. So it's a very early solar image from this telescope. Okay, so there's the shaft. So you see these kind of stair step things. I was sitting on that. So my guide said, well, you want to go up to the top? And I said, I didn't know what to say. So I said, yeah, sure. So we kind of hopped on and we went up the shaft. So you can see us going up the shaft, getting closer, and right at the top. There's another view of the heliostats. This is the catwalk going out. There's the Mile telescope. There's some really amazing views. When you go on some of these telescopes, you see the other telescopes, but from a really high vantage point. So at this point, I'm quite high up. If you remember the triangular shape of the Mcmath, I'm at the top now. And I said, well, should I walk out there? And I said, I'm only here once. So I walked out there and got quite a nice view, but I very quickly scampered back. It is an old telescope, okay. So windows on the universe. This is the new center that they're building in the Mcmath. So they're actually converting the Mcmath. Now they tell me they're going to operate it as a solar telescope and use it as a visitor center. So they're rebuilding this thing called Windows on the Universe. So it's quite an expensive project. I'm trying to remember how much it was. 4.5 million, it says. Yeah, it's going to be pretty amazing once everything is set up. So the WIN. So WIN stands for Wisconsin. This is Wisconsin University Telescope. It's a 3.5. You can see it right here. Every scope is a little bit distinctive. Like the outer shell of it will look interestingly different. Just like the Bach spray can, the WIN, the Mile, they all have a distinctive look. So inside the WIN, this is kind of quite interesting. A lot of, I can't remember what these hydraulics were for. I think this is the one that actually has, I think this one has, yeah, it does. Has activators on the back. So they carry hydraulics that allow the back of it to be distorted. So these little controls actually allow the mirror to be flexed in different ways. Here's another view. Yeah, they have a new instrument as well. Second largest telescope on Kitt Peak. Now this is an interesting observatory. This one was not very far from the workshop where I was taking my Pix Insight course. And it's, I think it's just used by, I can't remember which university, but it's kind of like a student's observatory. Oh, they're famous for pink flamingos. Can you spot them? So this is a Saturday night, just like our Saturday nights here. So people come up the mountain to watch the sunset, actually. I guess you guys do that too. Yeah, it's beautiful. The night sky again. It was really nice to be there and not have to leave the hill. If you're a visitor at Kitt Peak, you can't stay overnight. So if you take a course, you can. So if you're staying overnight in the dorms, you can do that. No more Milky Way shots. I thought this was kind of cool. I'm pretty sure this is Mars, actually, just above the Mcmath. So this is kind of like the end of the tour, but here's the big reveal. What happened a month and a half ago? Contreras Kitt Peak fire. So all that lush growth that you saw, a lot of it's gone, or much of it is gone. So it goes to show you how fragile these facilities really are. I think back on Siding Spring and Mount Stromlo in Australia as well, laid siege to wildfires. That's why we're so adamant here on the Hill, even here. There are a lot of rules surrounding our ability to be here. In fact, as volunteers, we sign waivers to say that we won't leave the Hill. Like if there's a fire, we don't leave the Hill because it would block fire trucks from coming up here. So they have very, very strict rules about that. So here's some footage from some cam that's nearby. You can see it was crawling up the mountainside. And if you look, cause was lightning, but within 2 weeks, it was 100% contained. So they did a really, really good job to stop it from doing more than it actually did. So here's the devastation from lower down the hill. You can probably see a dome up here. There's a dome, there's the Mile Telescope. So this is lower down. This is where, as I was driving up. So all this is treeless now. So the dorm that I stayed in, it's gone. Small shed, but as far as they know, they believe that most of the telescopes survived. They don't really know about the instrumentation until they get full tests. But at the moment, they don't have power lines. So there's no electricity. They're thinking maybe from 3 weeks to a month, they'll have electricity. There are also no data lines going up there either. So they're going to do their best. I talked to Casey the other night. He came to one of our astrophotography SIGs via Zoom, and he told us that they're doing their best. They're going to try to get things going again, but the public isn't going to be able to go up there until they're back in business as far as science is concerned, and then they will think about opening it back to the public. So it's going to be a while for us to be there. It also means that Windows on the Universe is stalled at this moment. I'm glad it didn't burn down because they had already built like half of it, half of the facility. So yeah, it's a fragile universe. Well, how much time do we have? 10 minutes? Well, maybe I'll take some questions. Anybody have any questions about what you've seen tonight? Any questions? Do you want to see a bit of the Sonoran Desert? I can show you that. After all, it is called Kitt Peak in the Sonoran Desert. So I did kind of travel around the Tucson area, and Kitt Peak is in the Sonoran Desert. So these are the famous Saguerro Cactus. They're pretty amazing plants. They're very, very tall. There was one that I think was maybe like 4 times my height. They're extremely tall. Birds like to live inside of them, apparently. They had amazing sunsets when I was there, and amazing kind of contrails and clouds. I always kind of anthropomorphize these things. Somebody scolding somebody, I don't know. I actually wanted to wander into this area, but I found out like it's a cemetery area, but apparently there are rattlesnakes there, so I didn't want to wander in at night there. And some more kind of amazing sunsets when I was down there. And this is on a dude ranch, actually. I wanted to get some landscape pictures before I went home, because you don't get that kind of stuff up on Kitt Peak. So I stayed a few nights at this dude ranch, and I thought, wow, cactus. This is a great time for me to do a nightscape. So I did it. But the funny part was these cactus were red and green. How come they're red and green? And actually, how come they're lit like Christmas trees? And then I found out later, even though I did get kind of an interesting night shot, this is the backdrop for weddings. I didn't realize this is the place people go to get married. And this is just one of the place where they photographed the bride and groom, actually. I was surprised. Here's a closer view. It was still kind of pretty. I was hoping this to be more natural, right? And not lit up by artificial lights. Yeah, so that's my view of Kitt Peak. Yes. Yes.
What makes the area where Kitt Peak is so perfect for?
Okay, so the question is, what makes the area around Kitt Peak so perfect? Well, one of the conditions that is needed is height often. Like we will like to have observatories that are high up, okay? And the other thing is it's dry. So dryness helps, actually. Yeah, it's one of the main reasons. And it's away from cities as well. So there's not a lot of cities around, and that's paramount, actually. And actually, even in some of the nightscapes that I showed you, you can see a bit of a glow. That's actually Tucson, actually. Any other questions? Well, thank you for listening. And I hope you go and explore the rest of this this place here. It's very, very special to us. If you haven't seen the Plaskett, I want you to go up there and have a look at the old equipment up there as well. And if the 16 is open, go look for those analog dials. Anyways, have a good evening.
Hi, that was a great talk by David. And now I am going to introduce Sarah, who is one of our university students, and she is going to be available to answer any questions that you have for our Ask an Astronomer segment. So if you have any questions, please just put them into the chat window, either in Zoom or in YouTube. And she is going to be ready and willing to answer anything.
Hello, everyone. Nice to meet you. If you guys have any questions, please let me know and I'll try to answer them to the best of my ability.
Now, I'm kind of a bit of a technical co-host here, Sarah. So I'm just going to see, maybe we can even have people unmute if they want to ask directly. If anybody wants to do that. And so I've just clicked on Ask to Unmute for everybody. Hopefully you can do it yourself if you want. And don't be shy, people. So what, maybe I'll lead off if that's okay. Sorry, just so what made you want to get into astrophysics? Like, what drew you to this oddball field where there's almost no jobs?
An amazing way to put it.
Well, I have a degree in it too, so I know.
Yeah. Well, to be honest, I think I've always been fascinated with the sky ever since I was a kid. And so I'm from the Middle East originally. So, you know, we would go out in the sky at night and just observe the sky and the stars and see what's out there. So I've always been intrigued in that sense. I didn't know that I can pursue astronomy until I got into high school. And when I got there and I was like, hey, like this is something that I can actually pursue myself. And I learned along the way as well that I also liked the way things worked and I just liked the physical aspect of it. So like the questions that physics answers. And so I thought of doing a degree in physics and astronomy together to see if I can actually like combine that or incorporate that into my life somehow. And yeah, I stumbled upon UVic and UBC as well, and I chose UVic because I just loved being on an island. So yeah, so I guess it's been challenging for sure, but I've always been fascinated with just how, you know, the nitty-picky things that go on in our lives every day. Yeah.
Cool. now that you're in fourth year, is that right?
I graduated from my degree in April, so I was done in April of
Congratulations.
this year. Yeah, thank you. Yeah, so I've just been doing particle physics research right now with
Wow.
a faculty member at UVic. Yeah, it's been great. It's been a journey so far.
Yeah.
Yeah.
So very cool. So do we have any questions from the other people present, or maybe from YouTube? If there's anybody on the stream on YouTube, might be a quiet night that way.
Mhm.
People might be madly typing here for all I know, but I'm just going to ask you, are you interested more in the theoretical side then, or have you been drawn to the observing side? You said you've gone out and you enjoyed looking at the sky when you were younger and so on.
Yeah. I think like when I first started, I was like, oh, like I love observing and you know, I love to actually go on like and observe myself in an observatory and things like that. But I think the more I got into the field, the more I progressed and I saw what goes on behind the theory, I think I leaned more towards the theoretical aspect. I mean, particle physics is experimental to some extent, but I did learn that you can actually combine like, you know, studying dark matter and stuff related to dark energy, which is the things that I'm really interested about in particle physics. So like the run 3 of the Atlas experiment right now at CERN is pretty big on that kind of thing, studying dark matter and the particles that go on, maybe the theoretical particles that go on behind it and stuff.
Okay.
So I'd say,
what is Canada involved in that? I guess
yeah,
clearly
yeah.
what you're doing, yeah.
Yeah, they're heavily involved in it, I would say. Even members at Triumph, which is the particle accelerator in Vancouver, they also do studies related to dark energy and the Higgs boson and the potential of dark energy and just measuring dark energy of the universe in general. They do lots of experiments and studies and experiments related to that. And UVic, UBC, McGill, even University of Toronto, they all have ties with Atlas and the CMS experiments as well. And you know, their research faculty also take on dark matter experiments. And so it's a growing field for sure, I think, in my opinion. And I think if people are interested in the cosmological aspect of astronomy, I think going into that field is definitely worth it. Yeah.
So that's interesting. So we've known for a lot of years they're trying to find these maybe little dark matter particles of sort. But they're doing experiments on dark energy in physics labs. So what on earth are they doing that way? Are they trying to detect particles, or what else are they trying to do?
So I've spoken with 2 people that have experiments that do dark energy, and so they're trying to measure the potential of the dark energy in the universe currently so far, and they do that by looking at the Higgs boson and seeing how its potential changes throughout the universe. And so we have a cosmological model of the universe today, but we don't know how it was back then. And so they want to see how that change happened and why. And if they can determine answers to those questions, then they can possibly come up with scientific reasoning or understanding of what goes on in dark energy. Now, for dark matter, we, like you said, we know that it has mass, and so we can predict, even though we don't know for sure. We can say that maybe it does have particles that goes on in there. And so how those particles, how they interact with the Higgs bosons can also give us answers into what goes on behind dark matter.
So you're trying to determine what the Higgs boson is doing in the distant past in the universe. So you're doing, but aren't you using telescopes to do that, or is it more?
Yeah. So part of it does use telescopes, yeah, for sure. Just because we want to observe the model of the universe around us to the best that we can. And so when we have better telescopes that look further off into the early universe, the better. And that's why the James Webb Space Telescope, can help us with answering questions like that. However, they also look at particle accelerators just because we can actually make these like high energy collisions in particles ourselves on planet Earth. And so particle accelerators like CERN and like Triumph actually study these directly. Fun fact, my supervisor also told me that, they do produce small black holes when these collisions happen at the Atlas at the Atlas collider. So it's pretty interesting. Yeah, but it's nothing serious, nothing dangerous. It's just small and it's just very unstable.
I'll take your word for it. So with with those things, could they like deter? Because apparently, like, you get really tiny black holes, they might evaporate, and you get Hawking radiation. Are they hoping to see that kind of stuff, or?
Yeah. So they try to see, we call them J size. So they're just events that have very, very high energies. So like just think of them as jet streams of energy that are produced from these high energy collisions. And so we look at these and we see what goes on behind them, and we try to trace their reactions, see if it came up from a photon hitting a boson, or like an electron hitting something else, and why they happen, or what their properties are.
Right. Cool.
Yeah.
I've been asking too many questions here. Like, does anybody else have any questions?
What's the latest in the James Webb? Like, what's come out this week? I heard something about one of the furthest galaxies that we've ever seen. So what's that about?
Yeah, so the James Webb, as some of you may know, it operates in the infrared, and so it can look way for more details than the visible spectrum can. And so we actually did capture an image of the oldest galaxy that we have ever discovered in the universe so far. And it's just amazing because of the structure that goes on in the image that the James Webb captured, or that could capture. And it showed lots of pockets or like what we call like deep empty spaces within galaxies. And that's when we know that stars are forming, just because they use the dust and the material around them to accrete onto themselves. And that's how they're formed. And so it looks like a spider web, and it looks very, like, wow, mind blowing. And it's just the amount of detail in it is just so much. But it is the oldest galaxy that we have ever discovered in the universe. So
I just glanced at it on a news site, and all I saw was a little red spot. But you're saying they're actually seeing some detail in that. I didn't take a close look. Wow. Okay, cool.
Yeah. So I think there were two pictures that came up for that galaxy itself, and the first one was the red one that you might have seen, which is just a blob of light, red light, and that is a galaxy. But when you zoom in and you apply not filters, but you actually look at the composition of the galaxy, and so you would see that there is a concentration of, I think it was hydrogen or some helium lines as well in it. And so that's why it appears purple in the other picture. So that purple color is actually what the galaxy actually looks like. So it's not just there for like as a pretty color for us to see. It's actually what the galaxy is made up of. Wow. Yeah, and there's just so much structure in it as well, just because, like I said, like there's these empty spaces in between. So that's why we know that the galaxy is still producing stars.
Amazing.
Yeah.
Okay. Are there any questions? We see a few people are still online here. I can do a what's up in the sky thing if anybody's interested, but we obviously have an expert here, so we should take advantage of it. Anybody's got any other questions? And thank you for doing this, Sarah. We really appreciate it.
My pleasure.
So, yeah. We might rope you back into more.
Yeah.
Quite likely.
Yeah, quite likely.
So Don, if you want to do what's up, that would probably.
Oh, sure. Okay. It's not nearly as current or anything like that, but I can do that. So thank you so much, and I'll take over here, and hopefully now it's traditional for me to kind of mess something up here with my presentation. So I'll see what I can do to make it entertaining if I do that again here. But what I'd like to do is maybe just show you, I'm just going to go a little bit earlier in time here because I've had this running for a bit. And so I just like to do a general thing like sunset and how long the night is to start with, just to orient people. So sunset is getting earlier. It sets at 8:53 Pacific Daylight Time. So just I think right around now, so it actually just happened 5 minutes ago. And at the end of August, it'll be at 7:57, so almost an hour earlier. So the days will continue to be warm, but darkness will start to fill our evenings more. And as I said in last week's talk, the evenings will start to get noticeably colder. And astronomical twilight tonight doesn't end until 11, or pardon me, doesn't begin until, let me change that again. Doesn't end until 11:18. And so that's still after our closing time for our Saturday star parties. But as we said last week, you can still make a lot of images with the Bach Telescope and see things through the telescopes in the parking lot. And morning twilight begins at 3:19 a.m. So that gives us about 4 hours of darkness. And so the moon's phase is at 5% tonight, meaning it's just a sliver of a crescent in the evening sky. And so I have it depicted on the screen here. It's very low down in the twilight, and this time is showing here as being right about now, as you can see. So if you're to rush out after this, you might be able to see it down on the horizon if you have a good view of the horizon. And so the highlight of August for amateur astronomers and campers is, of course, the Percy meteor shower. And it's one of the most reliable meteor showers. And unfortunately, this year we have a full moon that coincides with it. And but you can maximize the number of meteors that you can see by looking when the moon is low in the sky, especially around 4:30 in the morning. That's the bad news. So just before morning twilight starts, and when the constellation Perseus is highest in the sky. And so the Earth is colliding with a stream of debris from Comet Swift-Tuttle at this time of the year, and the effect is like driving into a snowstorm at night. Meteors appear to radiate from a point ahead of us, and in this case in the constellation Perseus. And while meteors can appear anywhere in the sky, if the point is high above us, then we'll be facing more directly into the stream, and we'll be able to see those meteors that are on the sort of the other half of the horizon half a lot better. And so that will maximize the number of meteors that we can see. So the parent comet was actually visible in binoculars in 1992, and I recall actually seeing it myself. And the next time it appears, which is in 2126, it'll be a bright comet visible to the eye. So it'll be about magnitude 0.07. So about as bright as some of the brightest stars in the sky. And personally, I can't wait to see it then. Being optimistic here, its orbital period is about 133 years. So it is a long wait between appearances. And I'm just going to shift stellarium here, just to give you an idea of what the nighttime sky will look like on August 11th in the morning. And so this will just take a moment. And I'm just gonna shift to the 12th here, but that's okay. And just come back a little bit. And so you can see the moon is down low on the horizon. That's actually going to help us a little bit, is that the moon has actually been lower than the ecliptic, the plane of the ecliptic. So it's been very low to the horizon recently. But the effect of the full moon is very much like having a street light above the Earth's atmosphere and causes a lot of air glow. And so the night sky will still be appreciably bright, but nevertheless, it'll be a good time to have a look. And if I can just do this carefully without wrecking the presentation, let me see if I can just get a few things out of the way here. And you can see the Perseid radiant will be very high up in the sky at that point. You can also note that there's some bright planets visible at that time. And I'll just mention a few things about that. So in the last month or so, we've had the planets strung out in the morning sky, and they have been arranged before sunrise in pretty much a line going down to the horizon. But now a couple of the planets are starting to move into the evening sky, and you can see that, let me just zoom out here a little bit, or zoom in, I should say. You can see that Saturn is down in the southwest early in the morning, and then you have Jupiter and then Mars and so on. And so these planets, these bright planets, Saturn and Jupiter, will be in the evening sky starting in August. And so that's something to look forward to, and they'll become more and more visible as the fall goes on. So there's one more thing that I tried to show last week, and unfortunately things got a little bit messed up, but you can see that the planet Mars and the planet Uranus are very close together here. I'm just going to click on Mars and try to zoom in again and hopefully give you an idea of how close they are together. And so they are quite close together in the sky, and so this is an opportunity to try to see them in the same field of view as a pair of binoculars. That field of view for a pair of, say, 730 binoculars is about 6 degrees, and so it's let's get a little bit closer here. Just double check that. Field of view is still about 9. And so they'll just kind of be at the opposite side of the field of view of a pair of binoculars right now. And so you might want to go online and try to find a sky chart that will actually show you some of the other stars in the field of view. But you might be able, if you're very lucky, you might be able to see a little bit of color to the planet Uranus, and it'll look a bit like a bit of a greenish color. So that might distinguish it from the stars. And so I encourage you to go have a look for it. I've never found it on my own like this, but I'm certainly going to try over the next couple of days. And so that's about it for this week. And I'd just like to thank everybody for showing up for a presentation and following us along on YouTube as well. So back to you, Amy. I'll try to stop sharing here. Okay. I don't know if Amy is still with us.
I'm still with you.
Oh, good.
So what do you think?
I think that's, go ahead.
I think that might be the night.
I think it is. Okay, well, I hope you have a great night on the hill, and that you get some great views.
Yes, there will be definitely there will be some viewing tonight. So that's a nice treat, I think. So
Terrific. I hope you get to look as well, besides doing all the important work you're doing.
Yeah. Well, thank you all for joining us. And of course, if you're in Victoria, remember that we're open during the day, during the week, Tuesday to Friday, 10 to 2.
Yeah, don't forget our gift shop, and that we take donations. We're a community-run organization, so we really appreciate any of the support you can give us.
Yes. Right. Thank you. Good night.
Okay. Good night.
Night.